That's just going to be the screen that I share. Dylan, good morning. Morning, Dylan. Can you hear me today?
Yes, I can.
Okay, excellent. Okay, so as I say, it's a very long topic. I'm going to need more than an hour, but I hope to not keep you much longer. Yeah. So year 13, you have new functions like the trigonometric functions that you don't integrate in year 12, and you have integration by parts, integration by substitution, so different methods, and then you have those wordy questions, mainly differential equations questions that can be a bit scary, but probably not that difficult as you think. Um, you have a list in your formula booklets in all of them on the functions that you can integrate, or I'm going to show you just for a second the Edexcel one. You have the integration list, but if you go previous page, and that happens with the AQA and the OCR, you have the differentiation list. So keep an eye on both, because sometimes with the differentiation list, you can integrate something that maybe is not in the integration list. Yeah, it's just a quick note. These are the polynomials. You know how to integrate them from year 12, adding 1 to the degree and divided by the new exponent, the exponential, the logs. So there are some, and these ones are not in the formula booklet. So all these, you need to remember how to integrate them, but they are quite simple. The ones that are in the formula booklet are these ones. I think you don't need to learn them by heart, but I would recommend you to remember that there are mix of cosec with tan and with cot, because then when you have a function like that in your working out, you will think, maybe this one is in the formula booklet. Even if you don't remember specifically which one it is, it gives you an idea of what is in the formula booklet. Yeah, so keep an eye on that list. So one of the very helpful things is to remember that when you are integrating a function of ax plus b, so a straight line, a linear function, so 2x minus 5, if you have the derivative, you don't need the derivative of that function, because the derivative of that function is just going to be a constant. So if I have 2x plus 3, my derivative is going to be 2. So if I have a function of that function, so if I have e to the power of 2x plus 5, or I have cos of 2x plus 5, any of these functions are going to be very easy to integrate, yeah, because I'm going to just need to divide by the coefficient or by the derivative of this function to have it, yeah. I'm going to show you with examples. Just my important note on this is, remember, when you have this function somewhere, it's going to be usually easy to integrate, yeah. So let me do a couple of examples. You have this one, for example. So the first one, you have cos of 2x plus 3. What are you going to integrate that? What are you going to do? Integrate the cos, which we know is sine. So the first one, we know is sine. Same function. And the only thing I have to do to have the derivative is multiply by 2. So if I integrate, I'm going to divide by 2. Yeah, so the first one will be just this function. If I have e to the power of that, what I'm going to do with that one? Can you try, please? Before I do it, it's quite simple, so it's quite similar. If I integrate that function, remember the exponentials don't change when I integrate or differentiate. The only part I'm missing is the 4. Because when I derivate this function, I will multiply by 4, yeah? And I should be adding the c. What about the last one? The last one, maybe you don't know it by heart, but you should remember that in your list, there are some trigonometric functions. So if you go back to your list, you see that sec squared, the integral of sec squared is tan, yeah? If you don't remember, maybe you even remember. So the last one is going to be what? It's going to be tan. My angle is 3x, and the only missing part is dividing by the 3. Yeah, that's constant. So it's very helpful to have a function of ax plus b, so something x plus or minus something, because we can integrate them very, very quickly. And even if they are a bit more complicated. So if you look at these ones, for example, how would you integrate this one? And again, it's because I have this function. If I have something different like x squared minus 3x, it would be much more difficult. But this one, how can I integrate this one? Who can tell me? Just imagine instead of having that function, you have x only. Dylan, what would you do?
Would you do ln? So maybe a third ln 3x plus 2.
You can do, because I have in the numerator the derivative of the denominator. So I'm not going to write even the ln. So it's going to be ln of 3x plus 2. And the only thing I'm missing is the 3. Yeah. So when you have this function, it's like having, 1 over u du. And you are integrating that. Yeah. Imagine that function is called u, 1 over u du. What about this one? I have something to the power of 4. So really it's like integrating u to the power of 4 du. Yeah? What is going to be then? Joseph, how can I integrate this one? You have the microphone? Yeah. Okay.
Yeah.
How do
So
I
you
u to the
raise power, and then so it'd be 1/10 2x plus 3 to the 5 plus c.
Exactly. So I have to increase the power, so 5, divide by the new exponent, 5, but then I'm missing these 2, so I have to divide by 2. Yeah, that's why Joseph said 1/10. Yeah, because I can multiply these 2. So when I differentiate this function, I have the 5 at the front, the 2 from the derivative, which is 10, cancel with this 10, and this 1 to 1 less. Yeah. So every time I have this function, I can think of u to the power of 4 du, or log u, or whatever. Yeah. Like if it's just one thing, and plus the constant of integration. Is this clear? Yeah. So it's very helpful to have that linear function. More. You're going to use for the equations or for the integrals, the trigonometric integrals, many times you're going to use the identities. So remember them, because it's going to be helpful to integrate. So you know that, for example, tan squared is not in your list, so you don't have tan squared, but you have an identity that relates tan squared with sec squared, and sec squared is in the list. Yeah. So sometimes just remember that the identities make your life much easier. So if I have tan x dx, I can say that this is 1 sec squared minus 1. Remember the identities that you learned this year? So in year 12, you learned sine squared plus cos squared is 1, and sine divided by cos is tan. This year, you learn this one, and the same but with cot squared and cosec squared. Yeah. And then I can separate. So the integral of sec squared I know is tan, and the integral of minus 1 is minus x plus c. So it becomes quite easy if you remember that you can write this in a different way, and that's going to happen in a lot of questions. So usually the trigonometric questions are going to be ready for you to substitute what you have into something else. Yeah, it's not going to be straightforward. Is this clear? It's quite simple. This one, I have to integrate sine squared. Some of you may know or remember, because some of you have seen this with me very recently. How can I integrate sine squared? It's something that if you don't know, it's hard to think, because maybe your first thought would be, I'm going to substitute that by 1 minus cos squared. But again, I don't know how to integrate cos squared. So what do you think you could do to integrate that one? Any thoughts? Dylan, what would you do?
Could you use the double angle formula?
Exactly. Yeah, and you have to remember that it's just, I would say, a trick. Every time you have to integrate sine square or cos square, we are going to use the cos of 2x. Remember, cos 2x is going to be cos squared minus sine squared, or is going to be 2 cos squared x minus 1, or 1 minus 2 sine squared x. Yeah, you don't have that formula in the formula booklet. You have the a plus b formula. Yeah, which means when you have cos of a plus a, which is 2a, if you change the b by a, you will have cos a, which is cos square, minus sine a, which is sine square. So it's not difficult to deduce. It's not, the double angle formula are not in the formula booklet, but as you have the addition formula, it's easy to find. Yeah. So with that, we can say that sine squared, so from here, I can write that sine squared x, sine squared x is 1 minus cos 2x divided by 2. Just making sine squared the subject from here. Yeah, from here. And I know how to integrate this one. Yeah, so I can substitute sine squared by 1/2 minus cos 2x divided by 2. Can you integrate this before I do it, please? So 1/2 goes into 1/2 x, and cos 2x, you have to be careful with the coefficients. So maybe you can do the thing, so integrate cos 2x and then think how you derivate, yeah? But I have a minus so far. Integral of cos is sine, so it will be sine 2x. Then I have the 2 in the denominator already, but I have another 2 for derivating this function. So this is going to be 4, really, yeah? Does it make sense? Yeah, so always check once you have adjusted the coefficients that when you derivate, you get what you need, because sometimes you realize, oh no, I'm missing a 3, or this is plus instead of minus, yeah? And then it would be plus c, but in this case, I have definite integral. I'm very sure you cannot see the numbers because they are tiny. I can barely see them by 8. I'm not going to do it, but you will have to substitute pi x, pi 8 here and here. Yeah, so you do a f of pi 8, always the first one first, and then minus f of pi 12. Calculator radians, because you have pi something, and then you find this one. If you do everything with a calculator, you have the risk of getting a decimal number. So just use it wisely. If you get decimal numbers, you know that you have to. It's not going to happen with sine and cos, but it will happen, for example, with the logs of the exponentials. Yeah? So when they ask you to write in a particular way, it's going to be a mix of calculator and head. Okay. Is it clear? Please remember that how you can integrate sine square and cos square, just in case you find it, because otherwise you don't know. And remember to use trigonometric identities to integrate functions that you don't know how to integrate. And it could be these ones, the 1 tan square, the sine square, cos square, but it could be the double angle identities. Yeah? All good so far? Yeah. Another example, we can do this one or this one if you want, just to use a few more of the identities. How would you do with this one, for example? Sine 3x cos 3x. I let you go for a couple of minutes to see what ideas to come from. And I have the list of, these are the ones that are in the formula booklet. Yeah? So think what you could do with that one. It's quite common if you have sine 3x, think how can you write that in something that you know, yeah? Do you need me to show you the double angle formula again, just in case? So you have them here. Sine, cos, tan, these are the double angle formula, in case you need them, yeah? What formula can I use to make that simple? what ideas can I use? If I try to separate, because sometimes you can separate this into sine x plus 2x and use the addition formulae. That is just going to make your question much longer because you have more terms here, but then it's going to multiply by 3x. There is a way of putting everything in just one. Joseph, what would you do?
Could you write it as, so using the sine 2x equals 2 sine x cos x, could you write it as a half sine 6x?
Exactly, that's it. So I'm going to put these two together. I'm going to collapse them into sine 6x. So if you think in the double angle formula, sine 2x is 2 sine x cos x, which means if I have here 3x, I will have here 6x, yeah? So 2 sine cos 3x is this one, except for the 2. So I can write that sine 3x cos x is 1/2 of sine 6x. Can everyone see that? Yeah? For people that I don't see, Hannah, Jenny, Oliver, yeah? And I know how to integrate this, yeah? So I can write the 1/2 outside, and then I have integral of sine is minus cos, so minus cos 6x, and I still need to divide by the 6. So I can put all the numbers together if you want as 1/12, yeah? Plus C. And this is how we can play with the trigonometric identities. If you try to do this one, we are not going to do it because I want to move on, but we have a bracket squared. I think probably your best reaction would be expanding the bracket. When you expand the bracket, you have sec squared, which you know how to integrate, tan squared, that we did before using the identity, and then sec tan, that is one in the list. Yeah, so again, it's quite simple, but you need to use the identity for the tan squared to convert it into 1 minus sec squared, sec squared minus 1. Yeah. Okay. Another thing is that, well, we mentioned already probably, but when you have the derivative, when you have an algebraic fraction and the numerator is the derivative of the denominator, just adjusting coefficients, is going to be ln, yeah? So here, the derivative of this one is 2x, so I have u prime divided by u. Every time I have u prime divided by u, this is going to be ln u, yeah? Adjusting coefficients. So the first one straight away would be ln x squared plus 1. I don't have to adjust any coefficients because the derivative of x squared is 2x plus c. Yeah? What about the second one? Jovan, tell me the second one. What would you do?
Would you try and differentiate the denominator you get to 2 cos x? But since that's quite small, would you put it as half?
You would put that as yeah. So I'm going to do 3 plus 2 sine x and half of that, or divide by 2. Yeah, exactly. Because when you derivate this function, you have, what about the sine? Is correct? Yeah, because derivative of sine is cos. Yeah, be careful with sine and cos, because derivative of sine is cos, but derivative of cos is minus sine. So always you have to be careful. And then these two, because the derivative of this function is 2 cos x. Yeah, plus c. So always try to, when you have an algebraic fraction, I think your first attempt should be check if the numerator is the derivative of the denominator. That's going to make your life easy. If that's the case, that's very easy. Another thing is if you have your function and multiply by the derivative. Yeah, it's similar to what we did with f of ax plus b. But when I have this function, the derivative is just going to be a constant. Now, when I have more complicated functions, I really need to look for the derivative. Yeah, you have one example here. You have sine squared and the derivative of sine. So really you have u squared and the derivative. So if you use the chain rule or the inverse chain rule, when you integrate that, you're going to have one more and divide by 3. Yeah, because when you derivate this function, it's going to be 3u squared, the 3 cancel with the 3, and then you multiply by the derivative of the function. Yeah, remember the chain rule when we differentiate. So in this case, I have something squared and the derivative of the something. So I'm going to increase my function by 1, and I'm going to divide by the new exponent. But I have already a 3 at the front, so I don't need that 3, really. Yeah, I can just cancel. Yeah, so this is the first one. When I differentiate this one, I have 3 at the front, sine squared, and derivative of sine is cos. So it will be precisely that one. Can you all see that? Yeah. What about b? So try to do b, please. I have the integral of x. Maybe you would try to expand the brackets, but it's going to be a lot of work, and definitely will work. So if you don't realize and you expand the brackets, then you have a polynomial to integrate, and that's fine. But it's going to be long, yeah? Okay. What do I have here? I have a function to the power of 3, and then the derivative of the function, just missing the 2, which means I can integrate that as function to the power of 4, so x squared plus 5 to the power of 4, so one more, divided by the new exponent, 4, and divided by the 2 that I have here missing, yeah? So I will have an 8 in the denominator. Yes? You see the steps? So try to look for, if it's not f of ax plus b and it's a more complicated function, every time you have something to a power and the power is high, and then you have the derivative, is going to be this situation. It's going to be u to the power of wherever and the derivative. If you have the derivative, then your life is easy. Yeah? So these questions are going to be prepared for that. Yes, for everyone? Move on? Yes? Hannah, Oliver, Joseph? Okay. Integration by substitution. This one and integration by parts are very powerful because they are going to help you to integrate functions that otherwise you have no idea of how to solve. In the questions, in many occasions, they are going to tell you, integrate using this substitution. So they help you, telling you the substitution that you have to use. Sometimes they say just using substitution, and then you have to think what substitution you use. And sometimes they don't tell you anything. If they don't tell you anything, it's because the substitution is quite obvious. So you have seen surely some questions where you have, I don't know, 1 divided by 1 minus x squared, and they say substitute x by cos theta, or something that you wouldn't have thought necessarily. So if it's a strange substitution, they are going to tell you. If not, are going to be functions where you have the square root of something, or you have a power to something, yeah? In this case, look at the function. We have this wonderful ax plus b, ax plus b. So if we have root of ax plus b, we know how to integrate that. Yeah, this is ax plus b to the power of 1/2. So it will be ax plus b. So if I have to integrate that, I will increase this by 1, so 3/2, divide by the new exponent, and divide by the a. Yeah, I know how to integrate that. The problem is that I have an x here multiplying. So this doesn't work because I don't have just a function of ax plus b. I have something else. It's multiplied by something. So we can do this question probably using integration by parts, but when you have a root of a function or a power of a function, it's quite helpful sometimes to substitute this by one letter, yeah? And then what we are going to do is to write all our integral in terms of that letter. So if I'm going to do, if I have u is 2x plus 5, what I need to do always is differentiate. So I'm going to find du by dx. Du by dx is just 2. which means du is to dx. And then with this, I'm going to go back to my integral and write every x in terms of u. Yeah, I don't want x's anymore. So I'm going to integrate that. X from here, if I make x the subject, I have u minus 5 divided by 2. Yeah, so I can write that. I can write u minus 5 divided by 2 all multiplied by root u. Yeah, I'm just substituting the x by this function and the root of u at root u. And then the x is to the is 1/2 of du. Yeah, so 1/2 du. I know it looks like I haven't done anything very helpful, but now it's going to be a polynomial, even if it doesn't look like. So let's going to get the numbers outside. So I'm going to write 1/4 outside, and then I have u minus 5 in brackets because the whole thing goes multiplied by u to the power of 1/2. Do you know how to integrate this one? Yes, you knew last year already, yeah? So it's a polynomial. I'm going to multiply, I'm going to expand the brackets. So u to the power of 1/2 times u is u to the power of 3/2, just adding the exponents. And then minus 5u 1/2 du. And this is very simple. I'm going to increase the exponent by 1. So I have u to the power of 5/2 divided by 5/2. Instead of writing the 2 there, I'm going to write it already in the numerator. Yeah, so divide by 5/2 is the same as multiply by 2/5. And then I have minus 5/4 u to the power of 3/2 and divided by 3/2. So 3 and the 2 in the numerator. I'm going to... Are you all following, or someone is I lost someone on the way? All okay? And I'm going to simplify a bit the coefficients that I can, so like these 2's, but I have to give my answers in terms of x, yeah, because I'm integrating in terms of x. So now what I'm going to do is instead of u, I'm going to write back my 2x plus 5, yeah? So simplify the coefficients a bit. And instead of u, I'm going to write 2x plus 5 to the powers that I have, 5/2 divided by 10, no? Minus, so I simplify this, and I simplify this. 5 2x plus 5 to the power of 3/2 divided by 6. That's the constant of integration. Yeah, and you can leave it like this. Obviously, you're not going to expand these brackets, but even if it's slightly easier, you still can leave it like this. Yeah, but you have to remember to not give your answers in terms of u. Sometimes I forget. I just leave the u and it's already integrated. No, you have to give your answers in terms of x. Yeah, does it make sense? So. And this, they are telling you to use this other substitution. You do exactly the same. You are going to find du by dx, and then you are going to substitute everything. So every time you have a root of a function, and it's not that easy option of the ax plus b, substitution would be usually a good option. And you're going to substitute wherever is inside the root by u or by u squared. Either way, I prefer this one, but it probably is. Both of them are easy. Yeah. Another examples of substitution. What do I have? These ones. I'm not going to do these ones, but quite similar. I just want you to think, how would you substitute? So you have x and x plus 1 to the power of 3. If you have only x plus 1 to the power of 3, so if I don't have this x, it's quite easy. I increase the power by 1, divide by the new exponent. But I don't have that. I have an x here ruining the whole thing. So I'm going to use substitution. What do you think is going to be the substitution? Who can tell me?
Would it be x plus 1?
Exactly, x plus 1. That's the substitution. What could be the substitution here? Looks a bit dodgy. Looks more complicated. But what could be the substitution? What do you think? Janie, do you have the microphone?
Would it just be 1 plus sine x to the power of half?
Exactly. Yeah. Or just 1 plus sine x. It could be to the power of a half or just 1 plus sine x. So these are typical questions of integration by substitution. I'm going to show you this one. No, it's not a trick. It's just something that is going to help you. But we have to integrate this one, and they say use u sine plus 1. Yeah, it's probably what you would choose because it's what you have in the bracket to the power of 3. So let's try to do this question and see what happens, because it looks like I have too many sines and cos there. So u is going to be 1 plus sine x, which means du by dx is going to be cos x. Yeah? And now I'm going to try to substitute. If I try to substitute sine x is quite a straightforward. So I have this bracket, which is u. Sine x is u minus 1. But then I have cos x. And cos x, it would be quite difficult to substitute in terms of u. So cos x would be square root of 1 minus sine squared, which would be 1 minus what? U minus 1 squared. So it becomes very annoying, yeah? Did you see something that is happening in this question that is going to happen in all these trigonometric questions that is going to help us? What happens? What do I have here? I have a cos, yeah? So if something is complicated to substitute and your derivative has a cos or a sine, this is going to help us. So instead of trying to substitute the cos, what I'm going to do is to ignore the cos and write it. So I can write cos, and then you have sine x, we say is u minus 1, and then I have u cubed, and then dx from here, dx is du divided by cos x. So I can write here du divided by cos x, and this cos x with this cos x are going to go. And that's going to happen in all these questions, yeah? So you're going to have a derivative there that is annoying, but it belongs to the du by dx. So don't try to substitute the cos x, because you see how crazy it becomes. Yeah? You're going to do the square root of 1 minus u minus 1 square, and it doesn't help. And if you have it here, it's going to cancel. Yeah? And now this is again a polynomial. It is u to the power of 4 minus u cubed, which is quite simple. So this integration by substitution help us enormously. So if you integrate this function now, you have u to the power of 5 divided by 5 minus u to the power of 4 divided by 4 plus constant of integration. And what you have to remember is to substitute again by x. So Dylan, tell me.
I'm just really confused. Where are you getting u to the power of 5 from?
Okay, I was skipping steps. So you have canceled your cos, and then you have u cubed. So you are integrating u minus 1 multiplied by u cubed divided by du. I expanded the brackets, so I have u to the power of 4 minus u cubed du. And that's where this comes from. So integral of u to the power of 4 is to the power of 5 divided by 5. Yeah? I was just skipping. I'm sorry. The last thing you have to do, please, is to substitute the u by 1 plus sine at the end. So this one becomes 1 plus sine x to the power of 5 divided by 5 minus 1 plus sine x to the power of 4 divided by 4 plus c. Yeah? So it's just a note, and this thing happens usually in the trigonometric questions. Yeah? Does it make sense? So in the trigonometric questions, try to remember that if you have your derivative, a function of x, it may cancel with some part that is difficult to substitute. Yeah? All good? Move on. You could do the same. I'm not going to do it, but it will happen the same with this one. Because the derivative, so if this is u, the u by dx again is going to be cos x. And this cos x is going to cancel with this cos x that we don't want. So when you substitute here, you are going to have your cos x being annoying, your u to the power 1/2, but dx is again du by dx divided by cos. And the cos cancel. So it's quite common. And look at that. It's just u to the power of 1/2, which is super simple to integrate. Yeah? Yes, for everyone? Okay. More. Integration by parts. Integration by parts is quite simple. You have a formula. It's in the formula booklets. What you are doing is u dv is u v minus u minus b du. So what you're going to choose is, in your integral, something as u, and then you're going to differentiate it to have the u, and something as the v, and you're going to integrate it to have v. So if you know how to integrate and differentiate both functions, I would choose as u, as you are going to differentiate it, as the one that becomes simpler when you differentiate it. So for example, a polynomial, if you have x squared, I would choose that as u, because when you differentiate it, it becomes 1 degree less. Yeah. If you don't know how to integrate one of them, that one is going to be the one that you're going to differentiate. So you have to think a tiny bit which one you integrate, which one you differentiate. But you're going to use integration by parts when you have a product of two very different functions. So for example, a trigonometric function and a polynomial, an exponential with a trigonometric. So something that one of them is not the derivative of the other, and they are not very related. So you want to split your integral, yeah? And that's the way. So here, for example, if we call u as x, because when we differentiate, it becomes simpler, du by dx is going to be just 1, yeah? Which means du is equal to dx. And then dv is going to be the rest, including the dx, yeah? So dv is going to be cos x dx. And I'm going to integrate that to find v. So v is integral of cos x dx, which is sine x. We don't need to add the constant of integration here, yeah? We are going to add it at the end. So I have u and du, I have dv and v, yeah? And then what I'm going to do is to substitute in the formula. So this integral here is going to be u v. U is x and v is sine x. So I have x sine x. Yeah, that's the first part. Then minus, and I'm going to do another integral. That second integral, the purpose of it, this whole thing is that second integral is easier. So sometimes you can do it straight away. Sometimes you will need to use parts again, but just once and then it's done. Yeah. So minus the integral of v, which is sine, the u, which is the x. Yeah, so v du. And now we know how to do that integral. Yeah, it's just sine x. So this is going to be x sine x. So the first part minus integral of sine, which is minus cos. So I'm going to change this minus by a plus. Yeah. And then I'm just going to add the constant of integration here. And this is how we use integration by parts to solve this integral, which is a polynomial and a trigonometric function multiplied together. Yeah. So I choose an u, I choose what is the v, I derivate the u, I integrate the v, and then I substitute in the formula. I will need to do a second integral that is going to be simpler. If not, I've done something wrong, or parts is not the best way of integrating this. Yeah. So if this becomes much more complicated, then there is another method. Does it make sense? It's quite simple and quite powerful, because otherwise you don't know how to integrate that. Yeah. Let me show you another one. This is another typical one. So you have x squared, so a polynomial, and a ln. How do you integrate that otherwise? No. So I'm going to choose u, and I'm going to choose dv. Can you try to do before I do anything? So think about which one you choose as u, as dv. I say, choosing x squared as u would be convenient because when I derivate, it goes down by 1. But the problem is that I don't know how to integrate ln. So if that's the case, ln must be u. Yeah, I cannot choose ln here because I don't know how to integrate it. I know how to derivate it, but not integrate it. So please try it. So du would be 1 over x, or du by dx, 1 over x, yeah? And v would be the integral of x squared, which is x cubed divided by 3. So it just becomes higher, but still is going to be okay, yeah? So I just integrated dv to have v. I integrated one. Let's substitute. I have the integral is going to be equal to uv, so ln x times x cubed divided by 3 minus the integral of v, x cubed divided by 3 du, and du is 1 over x dx. Yeah, so from here, du is 1 over x dx. So I'm going to multiply by 1 over x dx. And again, this is easy to integrate because it's a polynomial. It's x squared divided by 3. Yeah. So I'm going to have ln x times x cubed divided by 3 minus integral of x squared divided by 3, which is ln x cubed divided by 3 minus x to the power of 3 divided by 9. Yeah, so I divide by the new exponent and I have this 3 here. And then plus c. Yes? For everyone? Hannah, Joseph? Okay. I see the thumbs going up there. Okay, perfect. So that's how we apply. And these are the typical questions we apply, or exponential. So something we don't have more, but e squared or e to the power of x. So when we have e to the power of x and then x, or e to the power of x, x squared. Those are typical questions of integration by parts. You don't even know what to substitute by, yeah? Then you have, many times you have to integrate algebraic fractions. So you have a polynomial. And there are different options for that. So I would say, what options you have? So for example, when you have something like this, when you have to integrate partial algebraic fraction, my first option could be check if the numerator is the derivative of the denominator. Because if that's the case, we already have done this, it will be ln, yeah? Ln of x squared minus 3 plus c. That would be probably the first option and the easiest. If numerator is the derivative of the denominator, you have ln. Other option would be something like 3x plus 1 divided by x, or something like this. What would you do with this one? What can you do with this one? It's quite simple if you know. What would you do? Any thoughts? Numerator is not derivative of the denominator. Aim, you were going to say something. Tell me.
Can you just simplify it divided by the x?
Exactly. When I have only one term in the denominator, usually I can divide. So I can divide by x, and I have 3x plus 1 over x, yeah, or x minus 1. and I know how to integrate this one. Is 3x squared divided by 2 plus x minus, so I increase by 1. Oh no, this is 1 minus, is long, yeah? 1 over x, so this is ln x plus c, yeah? What else you can have? So sometimes you have something that is none of these ones. So the numerator is not the derivative, and I cannot easily simplify. So the next option that you have is separate in partial fractions. Yeah, so if your denominator, you can factorize the denominator or is already even factorized, the way of doing it is partial fractions. So you write your fraction as partial fraction, and then each of them, as you have degree 1 polynomials, and the factors are going to be degree 1, you are going to be able to use ln, yeah? And those would be the type of questions. Usually the questions are ready, and the first part of the question asks you specifically, write this fraction as partial fractions or something like that. That would be the first part of the question. And then the second part would be integrate that. Yeah. So usually the questions are telling you use partial fractions. If they don't, and you have factors in the denominator, that would be probably a clear option. Yeah. So then you will have to do the x minus 5 divided. Everyone knows how to write this as partial fractions, no? It takes ages, so I would prefer not doing it unless someone is confused. X minus 2. Yeah. So when you put these fractions together, you have a multiplied by x minus 2 plus b x plus 1 divided by x plus 1 x minus 2. And then numerator must be equal to the numerator. So x minus 5 is a x minus 2 plus b x plus 1. And then or you use substitution and you try to make one bracket at a time 0, or you compare coefficients. It's really up to you. If you compare coefficients, you have simultaneous equations. If you substitute, you find one coefficient at a time. So for example, if I substitute the x by 2 to have this 0, I have 2 minus 5 minus 3. This bracket is 0, and this one is 3b. So b is minus 1. And if I substitute the x by minus 1 to have this bracket 0, I have minus 1 minus 5 minus 6 is going to be equal to minus 1 minus 2 minus 3a minus 3a, which means a is 2. Yeah. Once I have that, this integral is 2 divided by x plus 1 minus 1 divided by x minus 2. And those are ln. Yeah. So it becomes quite simple. So it will be 2 ln x plus 1 minus 1 ln x minus 2. Do you all see that? I'm kind of going fast because I think this is quite simple. Some questions, they're not going to give you any clue. So if they don't say first, write partial fractions, and they don't give you the factors in the denominator, sometimes you don't know that is a partial fraction thing, but I think you can discard the other things. So I don't have in the numerator the derivative of the denominator because it will be 2x. So I'm missing an x. It's not that one. I cannot simplify. So what else can you do? Write partial fraction. So this one is going to be x squared. Sometimes it's x cubed, but very unlikely. So it's something x squared that you can factorize more or less easily. So it's not going to be one quadratic that you need the quadratic formula or anything very strange. So it's going to be easy. So they are not very difficult to spot, yeah? But keep that the idea as an idea. When you have to integrate algebraic fractions, it could be partial fractions, simplifying, or when you have the degree of the numerator equal to the degree of the denominator, like this one, yeah? So an improper algebraic fraction, you can divide first. So if you divide the polynomials, you get an expression much easier. So if you divide the polynomials, you have the 9x squared minus 3x plus 2 and the 9x squared minus 4. When you divide 9x squared, 0x, and then minus 4, when you do this, you have minus 3x, 2 minus minus 4 is plus 6, no? So this is the same that 1, your answer, plus the remainder divided by this one. So plus minus 3x plus 6 divided by 9x squared minus 4 dx. This bit is already super simple, and this one sometimes is simple again because you just have degree 1 or something. So it could be that this one is straightforward, or if not, how would you do this one? You can tell me. So this one, easy. This one, I don't have the derivative on the numerator because it's impossible to adjust the coefficients of both numbers with both numbers. Yeah, I will have this one. So what can I do with this one? Joseph, what do you think? Could we do what we just did with the partial fractions?
Yeah.
Yeah, because this one is very easy to factorize. Again, is 3x minus 2, 3x plus 2 is difference of the squares. Yeah, so it's the only possibility. I cannot simplify, I cannot divide, it's not learned. So the other option is partial fractions. Yeah, but if you divide, it could be that this one is completely straightforward, so it's just learned, for example, or you apply partial fractions to something a bit simpler than this one. So I would try to divide if the degree is the same. Yeah? Is this clear? Yeah? So we are going to use the integration in many questions to find areas. You did that in year 12, so now it's going to be the same, just we are using more complicated functions. We are going to integrate more complicated functions, but we are going to integrate between two values of x, the function, to find the area, like before. So, and if I have two functions and I have to find the area between them two, I can or subtract the functions and integrate, or integrate one function, find the big area, so find this area under the top one, and then find the area under the lower one and subtract. Yeah, so you can or subtract and integrate that, or integrate, and subtract. I would say this one, sometimes you find that some things cancel. So this could be sometimes simpler than this one, but it's really up to you, and you should get the same answer, yeah? I think I'm going to skip some examples because if not, there are too many. Parametric equations. Parametric equations, so remember you learned how to differentiate parametric equations. Parametric equations is when you have x in terms of a parameter and y in terms of a parameter. When you differentiate them, so when I do dy by dx, I can differentiate with respect to the parameter and just divide. Yeah? When I integrate parametric equations, I'm going to do y dx by dt. So I'm going to write my y in terms of t, like it is, and then the derivative of x, and then I'm going to write dt, and I'm going to integrate that one. If you have limits of integration because you are finding an area, be careful, because these are values of x, and I'm integrating in t. So every time I change my variable, I have to change my limits. Yeah, the same that if I use substitution. So let's try this one. We have to find the area, we have the curve. So y is 1 over 1 plus t. And then I have to write dx by dt. Dx by dt. I'm going to do here on the side. And x is, expanding this bracket, t plus t squared. So dx by dt is going to be 1 plus 2t. So I'm going to write here 1 plus 2t dt. And that's what I'm going to integrate. I'll let you integrate that function. Then we will think about the limits. I would like you to try to integrate. So think, how would you integrate this function? Because it's an algebraic fraction, and I want you to think, what would you do with that one? What do you think you can do with that? Anyone? I don't have, the numerator is not the derivative of the denominator, so it's not going to be long. I cannot divide by the denominator easily. Can I use partial fractions? It looks like I don't have factors in the denominator, but I have the degree of the numerator is the same as the degree of the denominator. So even if I don't have one term here and it's not very straightforward dividing, I can divide. Yeah, I can divide like I did in this one here. I can divide, and it's going to become simpler and probably very easy to integrate quickly. So I'm going to divide the 1 plus 2t, or it's better to write in order of powers down. So 2t plus 1 divided by t plus 1. I divide and I have 2t plus 2. I subtract, these ones are gone, and I have 1 minus 2 minus 1. So this means that I can write this one as 2. So my answer, remainder divided by 1 plus t, or t plus 1. Do you know how to integrate now? Yeah, now it's quite simple. Yeah. So again, if the degree is the same, you cannot factorize that. The derivative is not in the numerator. Try dividing. Yeah, you know how to divide polynomials, and now look how easy the question becomes now. So this is going to be 2t minus ln of t plus 1 plus c. Yes, does it make sense? It's clever, no? Yes, you just have to remember that you can divide. If you have limits of integration, instead of integrating between 0 and 2, you have to integrate between the values of t, yeah? So we have to choose what is, I'm going to clean this. So when x is 0, what is t? And when x is 2, what is t? So I can integrate. I know that x is this function here, so t plus 1 plus t. So I know t. I know x is t, 1 plus t. So when x is 0, I have 0 is t, 1 plus t. It gives me two solutions, t0 and t minus 1. I cannot integrate between two values of the parameter at the bottom and two values. I have to choose. Which one are we going to choose? We are going to use this one. Yeah, because usually, well, sometimes you can think, what would be if it's the negative or the positive or what, but it's difficult. T is greater or equal than 0, which means cannot be minus 1. Yeah, so I'm going to integrate between 0, and then x is 2 means 2 is t, 1 plus t. So that means that 2 is t plus t squared. So I have t squared plus t minus 2 equals 0. So t plus 2, t minus 1. I always do this. Yeah. So t is minus 2. That cannot be. And t is 1. So my other limit of integration is 1. Yeah. So I'm going to integrate, instead of writing the c, I'm just going to substitute by 0 and 1. Yeah, the limits. I can clean this. And that's it, yeah, in between 0 and 2. That's the important thing. You need to remember, and this is not in the formula booklet, but it's not difficult to, if you are doing integral of the function, the x, your function, you write it in terms of the parameter, and then you use a kind of chain rule, so dx by dt and dt, yeah? And the functions are usually not complicated. It's okay? Easy? Or not too easy, but okay. Okay. Perfect. Fine. Trapezium rule. You have numerical methods to integrate functions. Usually you use them for functions that you don't know how to integrate. But in the questions, sometimes they just give you an easy function to use the trapezium rule, and sometimes integrate it properly and compare. Yeah, because trapezium rule is just giving you an approximation. In the trapezium rule, we are trying to find an area between two values. So let's say these two. And what we are doing is splitting this interval in small intervals that are all equal width. Yeah, so this h is the same. And we are going to find areas of trapeziums here. Yeah, add them together, and that's going to be close to the area of the trapezium. The more intervals I have, so the smaller the interval is, the closer the approximation will be. The trapezium rule is this formula here. Is in the formula booklet and is super easy to use. Yeah. Usually the questions are going to ask you, so you have to integrate this function here, which is sec x. Usually they're going to give you a table that you have to complete, just finding the y's, because you need the y's for your formula. So in the formula, h is the width of the interval, and these values of h are going to be these values of h. So the function at those points. Yeah. So they are going to give you the values of x, usually the values of x, some values of y, and you have to complete one or two values of y. So to find these values of y, the only thing you need to do is to substitute in your function the x. Yeah. So when x is pi 6, you have to find sec of pi 6. You cannot find that with the calculator. You will have to do 1 over cos of pi 6. Yeah, but you know how to always find the values of y. And then once you have completed the table, is use the formula. So to use the formula, I have it here for you. The area is going to be approximated by 1/2 the width of the interval. If you have the table, the width of the interval is the difference between any of them. Remember, the width is constant through. So it's going to be pi 12. That's the width of the interval. So pi 12, and then you multiply the first y alone, then 2 times the other y's except the last one. So 1.035, 1.55, 1.414, and then the last one alone again. Yeah, because when we do the trapeziums, the area of the trapeziums, this y is in 2 trapeziums. Yeah. Well, the first one and the last one is just in one. It's just y. You don't. Oh, where is it? And then you find the value with the calculator. Quite simple. Sometimes you are asked to find the value. So to integrate, if it's a function that you know how to integrate, sometimes they ask you to integrate properly and compare. Yeah, or sometimes find even the error or something. One common question is they ask you if it's an underestimate or an overestimate. What do you think? So an approximating with the trapezium rule, is that going to be larger or smaller than the real area? What do you think? Dylan, what do you think?
Smaller.
It's going to be smaller, yes, because if I'm approximating smaller, which one is going to be smaller? Wait, the real one or the approximation?
The approximation is going to be smaller.
You think? Can you zoom in your head?
Oh no. The actual value is going to be smaller than the approximation.
Yeah, so if your curve is convex, yeah, so I'm doing this. When you apply the trapezium rule, you are doing, so you have your vertical lines here. you are doing the area of this trapezium, yeah? So all this area, while the real area is a bit below. Yeah, so when your curve is convex, you are going cutting straight away on top. So you are adding actually this bit to your approximation. So it's an overestimate. It's an overestimate because your curve is convex. And if you say that it's convex, that's perfect. Or if you do a little drawing or something like that, it's important that you picture that. So every time your curve is convex, we are cutting with a straight line. So our trapezium is going to be slightly larger than the actual area. Does it make sense for everyone? Okay. And the last thing you have in the chapter is differential equation. So differential equation is an equation where I have dy by dx equal to an expression that is a mix of x and y. Yeah, so it's giving us the change of something in terms of something. Most of the questions are going to give us a rate of change. So we are doing dx by dt or d whatever by dt. Yeah, and we have to integrate them most of the time. So what we are going to do always with these questions is we are going to separate the x in one side and the y in the other side, and we are going to integrate both of them. We need to include a constant of integration, just one, and in many questions you will be able to find that constant of integration because these questions are usually modeling questions. Yeah, so let me do one. So I'm going to write the dy on the left because it's in the numerator, so I'm going to leave this one here. And then the only y that I have is in the tan. So it's going to go here, 1 over tan dy. And in the other side, then I have dx, and I have an x, and 1 plus x squared dx. Can you see how I separate the variables? Yeah, so all with y on the left, all with x on the right. And now I integrate. What is the integral of the first one? Probably you won't remember the list. But I'm going to remind you the list. Maybe we can even copy. How would you integrate 1 over tan? Wow, where's the list? 1 over tan. How can I integrate that one? Oh, I'm super far away. How can I integrate tan? Any idea? Not tan, 1 over tan. I think I might have it. I might have it in the differentiation list. No, I don't have it. Ah, I have. Okay, why I don't have this in the list? I'm missing some of the list. Okay, look at this one. We have the integral of cot. Yeah, and I'm integrating reciprocal of tan. Remember, reciprocal of tan is cot. So it's in the list. I don't know why I don't have that in my list. So it's going to be ln of sine. Ln of sine. So the integral of this one is the integral of cot y dy, and the integral of cot is ln of sine y. And minus? No minus. Okay. And I don't have to divide by anything because my y has no coefficient at the front. So this is this one. Yeah, I can do 1 and 2 if you want. Let's write. So this is 1 and 2. Integral of x, 1 plus x squared. This one is easy. What is the first thing I'm going to check with the algebraic fractions? If the numerator is the derivative of the denominator, which is the case. So that's going to be ln of 1 plus x squared. Yeah. Remember when we integrate ln, we put the absolute value bars because there is ln of a negative value doesn't exist. So we have to be sure that that's positive. Yeah. So if I go back to my differential equation, it means that ln, Dylan, tell me.
Wouldn't it be a half ln 1 plus x?
Yeah, Yeah, true. Thank you. Because when we differentiate x squared, I have 2x, and I need that too. Thank you, Dylan. So if I go back to my equation, I have ln sine y on the left is equal to ln 1 plus x squared divided by 2. And now is when I add my constant of integration. You don't need to add two constant of integration because they are constant to be found. So it doesn't matter to have here 1 and then here 3 that have here 2. Yeah, so they can go together and it will be a different constant, but you just need to add one constant. And that's how we do them. So we separate variables, we integrate each of them, and we add a constant of integration. And I think the difficult questions are when they are modeling questions. Yeah, so I'm going to do one for you. Is that clear? Yeah, perfect. Modeling questions. So many times you are going to have the rate of change of something, and then you are going to integrate that differential equation to have a connection between the variables, and then they are going to ask you questions about that. So for example, this one, the rate of increase of population of microorganisms at time t in hours is given by this differential equation. So I have dp by dt is 3p. Initially, the population was of size 8. So initially, when the time was 0, p was 8. And I'm going to use that to find the constant of integration, 100% sure. Find a model for p in this form. So we have to integrate that differential equation and then make p the subject. How I'm going to integrate it? Separate variables and integrate. Please, start doing it. So try to integrate because it's super easy. It doesn't matter what you do with the 3. So the 3 can go here, or the 3 can go here. Your answer is going to be slightly different because you will have a 3 here, but you don't have it here. And the constant of integration will adjust that. So if you have the 3 here, your constant of integration is going to be different than if you have the 3 here. But your answer will be equally correct. Yeah, it's the same function, just written in a different way. So you are multiplying by 3 or divided by 3. So this is your function. We have some information to find c. If that's the case, you have to find c. If not, you're going to lose the mark. Yeah. So when p is 8, when t is 0, p is 8. So that means that c is ln 8. So we can write that ln p is 3t plus ln 8. We can write this, or we can find a constant at the end. It doesn't matter. I need p in terms of t, and at the moment I have ln p. So that means I have to get rid out of the lns. When I have logs in a question, I'm going to put all the logs together in one side and a number in the other side. So I have log 7x equal to 3. I need log something equal something. So that's what I'm going to do with the logs. I can write log p minus log 8 is 3t. Using the properties of the logs, I'm going to put these two together. And then if ln p over 8 is 3t, that means that e to the power of 3t is going to be p over 8, no? P over 8. So that means that p is 8 e to the power of 3t. So I have the equation in the way that they ask me. So a constant e to the power of 3t. So is perfect. Yeah. This is a constant. This constant is the initial population of organism, the microorganism. Yeah, 8. Because is when t is 0, this is 1, and I have 8. Yeah, but that's the model. If instead of finding the constant here, you want to work with c and finding later, it's going to work equally. Yeah, so it doesn't matter really. But that's what we do. So we have integrate the differential equation. we have found the constant of iteration, and then if you have to write your function in a particular way, you will have to work how you find it. Yeah, so it's going to be slightly different depending on the function. Does it make sense? Yeah. B, find to the nearest 100 the size of the population at time t2. Once you have the model, they are going to ask you questions. So to the nearest 100 the size of the population at t2. What I'm going to do? Substitute t by 2. Yeah. So I have my model, so I'm just going to make t equal to and find p. So p is going to be 8 e to the power of 3 times 2, 6 to the nearest 100, and that's my answer. So 3,227.4 to the nearest 100, 3 to 100. Yeah, microorganism. If you have units in the modeling questions, always give the answer with units. Yeah. Then C, find the time at which the population will be 1,000 times the starting value. The starting value was 8. 8,000 times, yeah, 1,000 times 8 is 8,000. So I'm looking when P is 8,000. So I'm going to my model and I'm going to substitute P by 8,000, 8E3, and find T. Can you find T, please? Yeah, I now know. So before I knew the time and I need P, now I know P, I need the time. So these questions are quite similar. If I divide by 8, I have that 1,000 is e to the power of 3t. If I take longs or just think of the definition of the long, I have that 3t ln 1,000, which means t is ln 1,000 divided by 3. Yeah. When you use the calculator, if you write ln 1,000, it will open a bracket. If you straight away divide by 3, you're going to get the wrong answer because it's going to do the ln of 1,000 divided by 3. So what you have to do is to write a bracket or do ln 1,000 equal. It gives you the answer, and then you divide your answer by 3. So be careful with lns or any log, sine, and cos, because the calculator is going to open a bracket, but it's not going to close it. So if you immediately do something after, it's going to include it inside the bracket. So be careful of closing the bracket or press equal and then do something else. Yeah, just because I've seen many mistakes with that. 2-3 hours or whatever this is, hours. Yeah. State one limitation of the model for large values of t. Any, I would say, thing that has a bit of common sense about the model will give you the mark. So think what would happen with this microorganism. It will mean that it grows to infinite. Yeah, so it's an exponential growing very quickly. It's exponential, which means this microorganism would grow to infinite very quickly, which is not realistic. Yeah, so they will die for something else probably. So this is everything you have in the chapter, which is a lot. I would like to do one exam question about differential equations, just to show you one question. But you have exam questions in the PDF, so I would recommend you to practice. In my website, if you go to betteryourmaths.com in resources, you have exam questions per topic, so you can go to the AQA or the Edexcel and find the exponential questions and practice more. Yeah, some of them have videos. The ones in the PDF, they have all videos. The ones in the website, not all of them. Is this clear? Do you understand how we work with the differential equations? These ones are, I think, the more difficult ones, or the ones that you find more difficult, I would say. So I have one modeling. So a gardener has a greenhouse containing 900 tomato plants, and the gardener noticed that some of the tomato plants are damaged by insects. Initially, there are 25 damaged tomato plants. The number of tomato plants damage by insect is increasing by 32% each day, and it can be modeled. So the number of plants damaged can be modeled by this expression here. A and B are constant. T is the number of days after the gardener noticed the damaged plant. Use this model to find the total number of plants damaged by insects 5 days after he noticed that. They are asking me X when T is 5, which means I need to find the model. So they don't tell me find A and B, but I need to find it. If not, I cannot find anything else. Yeah. What do you notice about what is happening? What type of function I have? What is happening here? So do you understand the question? It's increasing at 32% each day. What type of function or what type of sequence I have here? Japan.
So would it be geometric?
It's a geometric sequence. So it's not super obvious, but if I increase something by 32% every day, I'm really, bless you, I'm really multiplying. The first day I will have, so if I have A1, the first day I have 25 plants, but the second day I will have 25 plants times 132, 32% more. And the next day I will have A2 multiplied by 132. So this is a geometric sequence. Yeah, which means in general, I will have 25, my initial number of plants, and B is going to be my 132. So my model is going to be X is, and this comes because it's a geometric series. So you have to sequence. X is going to be 25 times 1.32 to the power of T. T is the number of hours that, or days, no, that pass. So it's very easy to find A and T, A and B. Another way of thinking would be using, so for A, you know initially, so when T is 0, X is 25. So you could substitute T by 0 and X by 25 and you get the A. But the B, the only way of thinking is that with the 132 increase. It's not easy to think otherwise. Yeah? How do we find what happens 5 days after? Substituting T by 5. Once I have the model, I need to find X when T is 5. So when T is 5, X is 25 times 1.32 to the power of 5. Yeah? Which is 100.1, something, 100.2. Do we have to round to something? Total number of plants damaged. Okay, rounding. Always in these modeling questions, think about your rounding. So when you are rounding in a normal question, no modeling, you're going to round to the nearest wherever. When you have a modeling question, think, because not always you are rounding to the nearest number. So if I have to round one, this is 100.2. If I want to round, because I'm counting plants, to the nearest plant, I would round to 100. But if I have 100.2 plants eaten by insects, I have like a plant kind of eaten, so I will have to round to 101 plants. So I have 100 plant ill or dying or whatever they are doing, yeah, with the insects. Does it make sense? Please, with modeling questions, think that having maybe a portion of something like this damage, it could be that you have to consider the thing damage. Yeah? So please look at the rounding. So we have 101 plants damaged by the insects. Then, explain why this model is not realistic in the long term. This is an exponential model. What happens in the long term with the exponential model and my tomatoes? What do you think? What would be in real unrealistic? Who can tell me? Dylan, what do you think?
eventually the number of points damaged will be more than 900. So
Exactly.
that's
Exactly.
impossible.
It's impossible. I have 900 tomato plants, and this is going to grow exponentially. So at one point, I will have more than 900 plants ill. Yeah, and it's not possible because I have only 900. So write that on your own words, and it's just a common sense thing. Yeah. And not just a common sense, but understanding what exponential model is something that is going to go to the infinite. A refined model assumes that the rate of increase of the number of plants damaged by insects is this differential equation, yeah? So we have x and t again, but in a differential equation. So that, okay, so that this dx is equal to this dt. So we have to not integrate, but prepare the question to integrate. We have to separate the variables and try to write this way. So let's go into separate the variables and think a bit, but I think if you see these A and B capital letters there, it sounds like partial fractions. So you're going to see that very quickly. Let's go into prepare that function to integrate. So x 900 minus x divided by 227. So we have to separate variables. The 2,700, so if you look at this trying to go here, the dt is completely alone. That means the 2,000 has gone with this part of the function, yeah? So dt completely alone and everything else in the other side. So I have 2,700 divided by x and 900 minus x. The x is going to be equal to dt. And I'm going to integrate both sides. What they have done with this bit is separating partial fractions, and that's what they're asking, yeah, to find a and b. So let's go into find that very quickly. If you find them, please type them in the chat because you're always quicker than me doing these questions. So I'm going to separate that into so I get a3 and then and b3 as well. Did you get a and b3, both of them? Yeah. Okay, excellent. So that's what they ask you in this part. They don't ask you to integrate yet. They say, so that you can write this way. We have done that and find a and b are positive integers to be found. Hence, find t in terms of x. Now it comes the fun. So we have to integrate that function. But we know how to, yeah, because we have now this written as integral of 3 over x plus 3 over 900 minus x, yeah? dx equal dt. So we are going to integrate 1 and 2. Type them here. Okay. So 1, 3 over x. If I integrate that, I have 3 ln x. If I integrate the other, I have 3 ln 900 minus x, and it's going to be a minus because the derivative of 900 minus x is minus 1, yeah? And this is going to be equal to t. I don't even need to separate them because it's quite simple. Plus the constant of integration. And now I have, I have to find t in terms of x. I need to find the constant of integration, yeah? I need to find the constant of integration, and then I have t is equal to all that. constant of integration. How I'm going to find that one? What I'm going to use? I would say the easiest thing to use is this bit here. When t is 0, x is 25. So I'm going to substitute t by 0 and x by 25. So I have 3 ln 25 minus 3 ln 875 is going to be the constant of integration. Yeah, so the constant of integration is going to be, I can, it would be better to have the constant in the other side and have it positive. It's okay. So I have 3 ln, I can put them together, 25 over 875. Yeah, that could be my constant of integration. Can we simplify that a bit? Yeah, 135. So you can write the constant of integration as 3 ln 1 over 35. That's your constant of integration, which means t is 3 ln x minus 3 ln 900 minus x minus 3 ln 1 over 35. Yeah, just putting everything together. Every time you have lns, it's not that you can eliminate, but you can use the properties to make just one ln. I would do that, yeah? So let's try to put all the lns together. So t would be, these 3 can go to the exponent, these 3 can go to the exponent, these 3 can go to the exponent, yeah? Or I can have a big bracket, so I can have ln, a big bracket to the power of 3, and then everything else. This x is in the numerator. This one is negative, is going to be in the denominator. I hope you are following me and I'm not getting too confused. And this minus is going to be in the denominator, but it's a fraction, so it's like having minus 35 to the power of minus 1. So it's going to go in the numerator, yeah? So this goes here, 35x. And that would be the best way of writing t. So instead of leaving all your logs separate, I think you are going to lose the last mark if you don't give all the logs put together. Yeah, it's 5 marks, so I think you should write all together. Does it make sense? Do you know what we've done? Every step, is someone lost with something? No? You can tell me.
It says minus 1 over 35, so would it be in the denominator? Because you're multiplying from top.
I can write this one as positive 3 ln 35. Yeah? And that's why I did to have the 35 in the numerator. So I just did the reciprocal, or how can I explain you to see that? So if I have minus 3, I have plus 3 ln of 135 to the power of minus 1. So I can bring the minus 1 as an exponent. Can you see that? And leave it positive. So when I do the reciprocal of the 1 over 35 becomes 35. Does it make sense, Jovan? Yeah, just a way of writing it better, I think. Because you will have to write in the denominator 1 over 35. If you write in the denominator 1 over 35, then 35 goes to the top anyway. It's another way of saying it. Okay, and that's t, and that's the 5 marks. And then they say, hence, find the number of days it takes from when the damage is first noticed until half of the plants are damaged by the insects. Half of the plants, we have 900 plants, no? So we just have to substitute x by 450 and find t. Easy, yeah? So the last bit, I don't want to go to the next page. Let me, Dylan, tell me.
Did we forget to integrate the dt?
Don't tell me that. Did we? No. I just didn't do in 2 separate parts. I did it all in once because it's very easy.
Okay.
So the left-hand side is this side, and then I integrate the t, just writing t and c. So I didn't do in two parts because it was very simple to do just in one.
Thank
Okay, and now we need to find t. So I think this is the t when the number of plants is half of them, which is 450. So I go to my equation and I say that t is ln of 35 times 450 divided by 900 minus 450 is 450 cubed. Calculator, let's see if we get a nice number. Always, well, actually I can cancel this, no? So it's ln of 35 cubed. Uh, 10.6, 10.66, so 10.7. This is days. This is days, yeah? So something like 10.6. Find the number of days it takes from when the damage starts to the plants are damaged by the insects. Yeah, so 10.7 days. They don't ask us to round. Sometimes they say in days and hours to the nearest hour or something like that. Always check how they ask you. If not, leaving 10.7 days is completely fine. Yeah. Okay. It's okay. The whole thing, we are done. I just hope it didn't feel too long. I know sometimes it's a lot of information. We get kind of, okay. Everyone is fine? Did you have any questions? No? Was it helpful? Okay, so please practice now before, when you have everything fresh, I'm going to process the recording of the lesson when Google upload it to my Google Drive, so it will take a few hours. Then I'm going to send you the PDF and the questions. If you want to start practicing some questions in my website, you will find it, but then I will send you the PDF together with the recording, just in case you want to see it again, yeah, or any video. Okay, good. I hope to see you tomorrow at 6 for the trigonometric equations. I think you are all coming, yeah? I hope you enjoyed the rest of the Sunday. And I hope it's sunny where you are, because here is sunny. How nice. Okay, bye-bye.
Thank you.
Thank
Bye.
you.
Thank you. Bye-bye.
Thank you.